So this is all new to me, this gentleman here. This is Edmond Locard. I don't know if I'm pronouncing that right, but I went ahead and printed this out. Dr. Edmond Locard, December 13th, 1877 to April 4th, 1966, was a French criminologist, the pioneer in forensic science, who became known as the Sherlock Holmes of France. He formulated the basic principle of forensic science. Every contact leaves a trace. This became known as Locard's exchange principle. Now, of course, every contact leaves a trace can be expanded to every contact leaves a trace at that specific location, but the perpetrator also takes something away with him. So additional evidence is added, as well as the evidence can be removed from a situation. That being said, this is actual detective type stuff, and this is the really, really great stuff when it comes to understanding nature. Because these days, academics, they're not trained to be detectives. They're trained to be parrots. They're trained to repeat what their professors tell them so they get A's and B's, and they can move on to the next level and next level, next level, and then get jobs doing whatever research there is to do. But that is the problem, because as people have seen previous talks, there are major deceptions there that need to be weeded out. But when the education is the deception, when the deception masquerades as the actual education, then you have a problem, because no matter how much more education you get, the deception is just going to be reinforced time and time again. It's going to become so ingrained in your mind that there's no way to break free of it. And that's for another talk. This talk in particular, or go ahead and read the abstract out to you guys. The single greatest contribution to the theory of detection in criminology was provided by Edmond Locard as his exchange principle. It is the notion that the perpetrator, nature or animal, always leaves some physical evidence at the crime scene or event and simultaneously takes some evidence away. 2 parts. This is to show that not all evidence will be immediately available unless it can be interpreted in a light that makes sense and is congruous to the other facts presented. This is to mean that nature and or animal will always leave their signature on the event and in turn are contaminated by it. Explanation is provided to tie in the general theory. And essentially, I'll link this to the bottom. You guys can read it yourself. Essentially, this is Locard's actual wording. This is taken from one of his documents. Wherever he steps, whatever he touches, whatever he leaves, even unconsciously, will serve as a silent witness against him. Not only his fingerprints or his footprints, but his hair, the fiber from his clothes, the glass he breaks, the tool mark he leaves, the paint he scratches, the blood or semen he deposits or collects, all of these and more bear mute witness against him. This is evidence that does not forget. It is not confused by the excitement of the moment. It is not absent because human witnesses are. It is factual evidence. Physical evidence cannot be wrong. It cannot perjure itself. It cannot be wholly absent. Only human failure to find it, study, and understand it can diminish its value. And I put that in bold. Only human failure to find it, study, and understand it can diminish its value. So the evidence is there. The question is, can the evidence be interpreted correctly? And that's what we're dealing with here. In specific, I'll go ahead and read this out. You guys can read this. It's already on Vixra, so you guys can read along with me if you want. The velocity of hydrogen gas at temperatures above 120 Kelvin is high enough to escape Earth's gravitational pull. Hydrogen gas can escape into the atmosphere. That's why there isn't any hydrogen gas in our atmosphere, and if it is, it's high up in outer space. Yet, hydrogen exists in large quantities on the Earth combined with other elements, taking the form of molecules such as water, various rocks and minerals, composing plant and animal life, and even buried deep in the interior of the Earth, combined with carbon in the form of natural gas. The hydrogen's here. There's lots of hydrogen. It's combined with oxygen making water. We have a hell of a lot of water in the oceans. and inside of rocks and minerals. That being said, if the Earth was hot when it was forming, around the same heat as liquid rocks, or about 1,000 Kelvin, then the hydrogen would have escaped Earth's gravitational pull very easily and never combined into molecules in any large amount. Hydrogen is very light and has a high velocity even at low temperatures, so it had never been pulled in by Earth's tiny gravity. This explained is when the Earth supposedly was forming, according to the dogma, it was really small, and then the rocks clumped together on top of it over time, which is problematic because there wasn't a gravitational field strong enough to pull in the hydrogen. So how did the hydrogen get onto the object? If the hydrogen was too light, it would always escape when the Earth was forming. There's no mechanism for that. The oceans would have evaporated as well, as water vapor at 1,000 Kelvin would have had enough velocity to escape Earth's pull. Earth couldn't even have held on to any water if it was forming like that. The water would have escaped too. So where did the oceans come from? What they do is, the meteors in the comets, they brought water here. Highly unlikely. Oceans would not have formed if the Earth wasn't its current as-is mass when it was forming from rocks clumping together as accepted by the dogma. So it's a paradox. How did light elements in huge quantities form molecules on the Earth during its formation if they would have easily escaped the lava world? The paradox is easy to solve. Earth was easily a gas giant well in its past, which explains the prevention of atmosphere loss. All the molecules formed on Earth were formed when Earth was vastly larger. When the Earth was collapsing from a much larger state, the hydrogen in the star stayed put. Of course, some of it escaped, but I'm getting into that. A larger gravitational field would prevent the hydrogen from escaping. Instead, it would be compressed and form molecules in chemical reactions, the same chemicals we find in rocks, minerals, life, and found buried deep in the interior of the Earth. All smaller rocky bodies in space that contain hydrogen were individual stars or remains of collisions between evolving or dead stars. There is no other way to trap the hydrogen during formation unless the gravitational field is big enough to allow for molecular synthesis of the hydrogen into heavier molecules. This being said, I'll read this out to you as well. So the missing evidence, the evidence removed by the process of stellar evolution, mind you, the process of stellar evolution means as the star is really big, hot, has a lot of hydrogen, it loses its hydrogen as it evolves and shrinks and collapses, is the fact that Earth has very little hydrogen as opposed to heavier material, but that is the path stars take. They lose their hydrogen if it does not combine with other elements on large scales. They lose their molecular hydrogen. That's a fact. That's what stars do. Yet the trace amounts, the evidence of Earth having been vastly larger, vastly more massive than its current size, is the fact that the hydrogen is here and is combined with oxygen and rocks and minerals and life on the Earth. So the scientific detective can take 2 bites of the proverbial apple. As well as there are technological advancements in astronomical imaging and processing so that stars that no longer shine should be found as well. They should be observed to be losing large amounts of hydrogen gas, and the researchers have found them. They are called hot Jupiters. So not only do we have evidence that Earth had to have been much more massive in its past to hold on to the hydrogen to form the elements, or to form the molecules the hydrogen is composed of, such as hydrocarbons and rocks and minerals and water, but that the vast majority of it is already gone. So think of it as a murder case. If you have a murderer, and I have this in the paper too, if you have a murderer go into a house with a knife, right? He stabs somebody to death, okay? There's fingerprints on the weapon. There's marks on the person's body of what marks the weapon made. Naturally, the murderer is going to take the body, which is the evidence, and the knife, which has a lot of evidence, and then they're going to remove it from the scene. So the main evidence that the detective can use to solve the mystery is gone. They don't know where it's gone. That being said, there's also trace evidence, and this is where Locard's principle comes in here. There's going to be fibers of the guy's jacket or clothing in the house. There are going to be boot prints outside. There's going to be vehicle track marks of how they transported the body away from the house. There's going to be evidence there of his presence, which is inadvertently going to give him away and tell the detectives what actually happened. The same thing is with Earth. When Mother Nature makes something the size of the Earth, she doesn't just remove all the evidence of it. There's evidence here, and that's the hydrogen. The evidence is, okay, sure, people say, well, the Earth isn't as massive as the Sun. Well, of course it isn't going to be. But there is trace evidence because we have hydrogen here. And the hydrogen can easily escape Earth's gravitational pull because its average molecular velocity concerning above 120 degrees Kelvin would easily escape. So how did the hydrogen get here? Well, it had to have formed with the rocks and minerals when Earth's gravitation was a lot stronger, and the actual physical conditions of the interior of the Earth were a lot more compressed. We're talking gigapascals right on the surface when the surface was formed in the interior of the star. So that being said, we have the ability to discover how things work, but we have to be able to look at things in the light of being a detective about it. We can't take assumptions and make those assumptions real and then force those assumptions to apply to what we're seeing. We have to first question the assumptions. A detective doesn't walk on a murder case and say, well, I know what happened. No, they don't do that. You can't take assumptions into a mystery and then force the mystery to conform to what you already believe. That's what astronomers are doing. They're saying, we know how planets form, we know how stars evolve. Now, what the hell is all that up there? We don't know. Well, naturally, it's because you've taken your assumptions and you made them true before you even started doing any detective work. And that's their problem. All right, guys, today is March 25th, 2019. Later.